Good morning. It's a slow Friday morning. A few people are on. I see 12 people are here. Hi. Rafael, Gabriel, Walter, Carlos, Von Marie, Ariette, Tiana, Jennifer, Ivana, Alexander, Laura. And then on Isaac? Or is it Isaac? Yes. I said you don't have to use your real names, but it's fine if you do. I think it's fine. So, on Isaac, okay. Alright, so I just popped up the prep questions, but where do you want me to start today? I gave you everything, right? I gave you all the solutions. I shared all the documents with you. Where should I start? I gave you all the solutions, I believe. Let me verify that I gave you the solutions to the prep. Let's see if I gave you the solutions to the prep. Yeah, I just gave you the question 217, and the solutions. Okay, I gave you everything. Good morning. You guys don't see. Why don't you see what I have up there? I see the chat. What's happening? Well, let me reload. So if there's ever any problems with the feed, just reload. Oh, there it is. Okay. Oh, it's interesting how it gets stuck. I have a quick question, review 1, number 6, and review 1, continued, number 1. I know my titles are strange, but they help me remember what's in the questions. Okay, review 1, number 6. Okay, I'll just pull up the solution for review 1, number 6. Document 2.7. Let's see if there's any errors here. Two point seven. Okay, Tiana, ask me your question and I can answer or step through the whole problem. All right, yes. So the calculations are done with t equals 6, but I thought it was 7. Okay, so why did I do that? So let me demonstrate why I did that. You see here all these cash flows. That's okay that you see these are 6 that make up the 6 payment annuity. Why did I do that? That's the question. The reason I did that is because the second part, the B part, uses, starts here. It starts at 6 because remember, for growing annuities, if you look at the pattern, go back to your notes and look at the pattern for growing annuity. So let's go through this and remember, look at the growing annuity pattern. You see, and I did mention this, but you know, you're still practicing, you're still learning. For the growing annuity pattern, the valuation, so we figure out the price of the annuity or the value of the future cash flows starting one period from now, with growth starting 2 periods from now. All right? So the first cash flow has to be 1 period away, and then the second one includes growth, and then the third one includes 2 periods of growth, etc. That's the pattern. So I only see that pattern let me erase this one. I see that pattern starting here. First cash flow 1 period from 6, and then growth 2 periods away, and so on. Oh, you're right, it's not a growing annuity, it's a growing perpetuity. Same thing. Same thing for the perpetuity. Let's confirm that, what I just said, because I used the wrong formula, but they're related. So, you see? No, not there. There. Growing perpetuity, the same thing. Growing perpetuity, we find the value here where the first cash flow is 1 period from now, and then the growth kicks in forever. Same pattern, except that this goes on forever, which is what we want. That's the pattern. So that pattern only exists here at 6. So that's why I can use all the other ones for the annuity. I use the other ones for the annuity and then leave the rest for the perpetuity. So you have all the solutions, which means you're just reading through them, but I suggest that you sit down and you try and solve these problems without looking at the solutions first. Okay, that's how you should be using these documents. It's not, you shouldn't just be reading them. It's not going to be enough, because in the test, you're going to actually have to write the answer down, right? You're going to need to know, because I'm leaving it as open book, you need to know where you have to find the answer. But you should be pretty good at this, so if I can give you a twist in the questions, you can handle it. All right, I'm going to read the questions you posted. So the reason that it works like that is essentially because of the formulas. I wrote out in 2 years, dividends on X stock will begin to experience growth in 2 years. So that's why I wrote growth starting at the second year. But then looking at the timeline, in this case, I really needed the timeline to visualize this. So that's why I drew it. And so you should always draw the timeline for payments, especially payments with growth, to be able to isolate the portions that apply to the formulas. Okay, so I'm going to check Jennifer's question, unless Tiana, you still have a question. Do you get it? Do you see it? Do people see this? So this was document 2.7. Let's see. Okay, Tiana, you also asked for the review 1 continued, and then I'll go to Jennifer's question. So review 1 continued, number 1. Okay, let's look at the conversion. So in this problem, we have the effective quarterly rate. The effective quarterly rate from problem 5, it says the required expected rate of return for investors is an annual effect. So the key word, even though I've underlined the whole thing, is this word. Annual effective, those 2 words. That's basically EAR. So what I do, remembering that for conversions, when we go from effective to effective rates, this is what we're given, this is what we need, and we draw the equivalency. So part of that long string of equalities that I gave you. Out of these two, EAR and EPR, which one is smaller? Think of it like that. So what you would do is you would write, and you need to write these out. You need to show me what you're doing. And if you have a better way of doing it, do it, but I need you to show me this notation so I know how you derive the answers. If any of you have taken actuary classes, you might have different symbols, but I prefer to use, if you're an actuary, then you're really smart if you're studying actuarial science, and you should be able to use my formulas so that the grader can mark it. Otherwise the grader might not be able to see what you've done. So between the quarterly effective rate and the annual effective rate, how do I make these equal? Which one is smaller? The quarterly one is smaller, and there's 4 factors of quarterly growth in 1 year. So that's where that equation comes from. So then I put in the values. I would put in, I guess I kind of skipped a step here. So you would write, or you would solve for one, anyway, I'll just do the extra step. So this is, the story of my iPad is that I bought a new iPad, but it's not compatible with my old computer to stream. So I have to figure out a different way of streaming the feed. Unbelievable. I kind of anticipated that happening, but I really don't want to buy a new computer right now. Maybe next year, well, when the new MacBook Pros come out, I want to get one. So what you do is you solve, oh, sorry, I was going to put the number in here. So the EAR, we were told, is 0.3, so let me just write that. So this is 1.03. But what I have to do is take the whole year rate and divide it in 4, but not divide on bottom. I divide in the exponent. So I'm putting it into fractions in power terms, factor terms. So that's why it's 1/4. Sorry, what is this minus 1? You're probably, what is that? There, that's what it is. You see what I did? And then the minus 1 is the solution, because the effective quarterly rate. I left you with a lot of stuff, so if you're confused, that's okay, you're still learning. If you're not confused, that's great, you learned from the documents. But it's fine, we're going to spend today solving problems. There you go. That's why I do it like that. Okay, so that was answering someone's question. Ariette. So Ariette, is that all right? Okay, so the second part. Sienna's, for this problem, what's the second part? So the second part, you mean step 2? Jennifer, I mean Tiana? Okay, let's see. Oh, you want me to go back to question 6? Okay, I'll go back to question 6, because that's why there's a quarterly rate like that, Ariette. If you're still there. So then you solve that and store it and use it in the perpetuity formula. Okay, I'm going to go back to 6, the second part. So that's why that worked like that. So what we have to do is the annuity, and then, okay, so then we have the annuity, which has the valuation at 0, but we have a growing perpetuity that has the value here. So in this lump sum are all these future payments. So we don't consider anything being here anymore, okay? Everything has been reduced to this number. Then this number is going to have to be considered because we can't add this part and this part because this part is in year $6, quarter $6. So that needs to be discounted as well because of time value of money. So we need to discount that all the way back. How many periods? 6, right? So that's why we have, for the part A, it's the regular annuity for 6 periods. And then for part B, we calculate the lump sum amount as a growing perpetuity and discount it 6 periods. That's why that happens. Now we can add those together. So first I get this amount and I store it. And then I get this amount with these steps and I store it and I sum them. So why don't you guys try it? Make sure you can get it, okay? I'll give you, some people maybe never did this yet. Let me give you a few minutes to work on that. So this is what we need to do. Part A plus part B. You have to just keep track of all your calculations and not round intermediate calculations. So Tiana says she got it. How's everybody else? Let's see if a couple of you can solve this. Okay, so you should be able to get this answer, the final answer of this problem, is $912.21. So all of these payments in the future leads to the answer I'll have to go back. $912.21. Exactly. You should have the exact decimal places, or in a test, you will lose points. Oh, did I write it wrong? $21.12. No, $12.21. Okay. Okay. That's fine, not yet. Okay, anyone get it? Anyone interested in getting it? You're still working on it? Who's working on it? Again, if the screen gets blurry, just refresh. Let me know if you're working on it, or I'm going to go to the next question. Hello, Valeria. Shoot, sorry, when I do that and zoom out, it affects the screen. Okay. Alright, Tiana asked me to do review one, continue number 1. If no one's interested in solving this one that I have on the screen, then I'm just going to go on. Okay, so this is document 2.9. 2.9. Jose is considering buying a business on December 31st, 2016. The business is for sale for $14 million. Jose hired Maria to analyze if $14 million is a fair price for this business. So Maria needs to find the fair price or the maximum price Jose would be willing to pay. So this is the information she gathers to use in the analysis. After thorough analysis of the food distribution industry in Puerto Rico and projecting potential sales and expenses, Maria developed the following projections of cash flows for the company. Between 2017 and 2022, the company will generate end-of-year cash flows of $1 million. And then between 2023 onward means forever. It's 1.5 million annually. You're told that she's going to use the 11% effective annual rate because that's the rate for her money, her investment, or the reinvestment in the firm. So the firm is expected to offer 11% return on investment. So she's going to use that as her discount rate, as though if she wasn't investing, or Jose wasn't investing in the company, he would be investing other places. So this is the appropriate discount rate that he'd be searching for, 11% expected return. So that is the one we're going to use. And so what's your question, Tiana? Hello, Ricardo. Okay. Yeah, it's going to happen forever, annually, onward. So in a corporate structure, we can anticipate, it's a legitimate assumption that cash flows accrue forever because the corporation could theoretically exist forever. Ownership can be passed from living person to other people and other generations by selling it or donating it or whatever it is for the stock. They could pass it on because it's transferable ownership, and the owners aren't necessarily the managers. Okay, is that all? Then Jennifer asked me a question. Jennifer asked me for 2.9. Unless you have any questions about 2.7, that's on the screen. not, no, sorry, it's two, what's on the screen right now? I have, review 1, 2.9. Oh, I did it again. Not good when I zoom out. So 2.9 is this one. Part B. Second question, second part. Okay, so let's go to second question, second part. All right, this is really important. You wish to obtain, I have to read from the beginning, a $200,000 mortgage from the bank. So you're going to borrow $200,000 and you're offered a rate of 6% per year compounded monthly for 25 years. Now, since they're telling you this is a monthly compounded rate per year, and those are not the same interval, you need to convert this, right? And the conversion is from the stated rate, you need to divide by 12. Why? Because that just represents the simple interest. So what they did to get this rate is they took the effective annual rate, the actual rate that's being charged on outstanding balance every month, and they just forgot about time value of money. They don't care about it. All they did was say times 12 as though it's simple interest. So to get to the effective rate that you need to divide. Okay, so you need to take the annual and divide it into the fractions that they neglected. So it's 0.005. So I find here what the monthly payment should be. If you find errors, let me know, okay? Because I had to edit a few of these recently. Just want to make sure I have all the right numbers and we agree. Okay, part B. Oh, to get this, this is a annuity where you're solving for payment. So you would plug this in your calculator as 25 times 12 months is the number of months that go in your calculator. It's 300 months, right? So 300 goes into N. And then interest, this is easy to punch in, but you have to remember you need to put this amount times 100 in your calculator, right? Because that's a decimal. So that goes into a percentage now. And then you already have the PV because that's how much you borrowed. Payment is what you want, so you just plug in 0 to future value and you ask for, because this is a positive, just to clarify that it's going to be a positive because that's what is a cash inflow, and then you're going to compute payment, and that's how you get that answer. So for the test situation, I want to see this formula. I want to see, in a test situation, I want to see this and this formula and the solution. And it's nice if you circle the final solution so I know, or the grader can find it easily. So that's part A. For part B, at 5 years from now, or after your 60th payment, right? Because 5 times 12 is 60. You have the opportunity to refinance the remaining 20 years of the mortgage at 4% per year compounded monthly. So you need to convert that as well, because this is per year and you're compounding monthly, so those don't match. You have to figure out that new rate. First of all, though, the first step of this is to find out what remains in the balance of the loan. So I did do this problem, this type of problem, in the document called applications. It was called interest rate conversions applications, or 2.5 is where you're going to find that. So see the document 2.5 for this, if you don't know what I'm doing. But what I'm doing is saying, well, these are the payments. The payments will stay the same until the loan is paid. So after 60 payments, that leaves 240. So that's how I can, in a fancy way, figure out the balance. So that's the balance after the last payment. So 60, at present value 60. So this is like at time 60 months. You will have made the payment here, but the next one, the new one at 61, we're going to have a new loan. Or let's write it, I'm going to call it payment star. So what you're doing is essentially getting a new loan. You're arranging for the bank to pay off your current loan, and then you get a new loan with new terms. That's how it's new. So when I do that, I make this payment, and that's not considered, but one period before the first payment is where I get the valuation. Oh my gosh, things moved around. Okay. So this is the valuation of the future payments. So it starts one period from now and goes until the end. Of 300. which you cannot see. Let me fix that view. Okay, let's see. Maybe let's make sure I have the right numbers. Okay. So to solve this, you need to use the original rate. But the payment can be rounded to decimals, to decimal places, because payments are made in dollars and cents. So what I'm going to put in is 240 as the N. The original rate of 0.005 times 100, which is just 0.5. The PV is what I want, but the payment is 1288.6, which is a negative. Putting 0 in future value, I compute PV, and I get exactly that number. So there's something you're doing wrong. Maybe you're using the new rate rather than the old rate. So let me clarify. This one is going to be 0.005, the original rate, because I want to figure out what the remaining balance is before I introduce the new rate. How did you do it? So it's going to be 240 that goes into N, because I don't solve this analytically. I use my finance calculator, and then I enter the interest rate, which I told you we have to put it in a decimal, a percentage. And then PV is what I want, so I tell the calculator that this is the payment. With a future value of 0, and then I compute. And if you compute PV, you get this. Exactly. See, I usually know the mistakes. It can be confusing, but no, you need to figure out what's left. So you need to use the original rate. Then you figure out the new payment and use the new rate. Okay, very good. Okay. So let's see. Anybody else have questions? About any of the documents I shared, and don't be shy if you have to go back to earlier ones. sometimes we just make the same mistake from the basic principles, and that can mess us up. I had a student once who failed everything, and finally everything. I'm saying, like, because I was giving quizzes in class and then the test, and she was failing. So I noticed. I went to her and I said, "What's going on?" And she just said she can't get the numbers out of her calculator. So I sat down and figured out she was entering things wrong. That was it. She went to become an A student. So it's very important to resolve those fundamental concepts, understand them, know how to use your calculator. All those foundational issues need to be resolved first. Okay, Adiyet, still going back to that. So why are we using the old rate? We're using the old rate because the first part is to find what the remaining balance is. How are you going to figure out the remaining balance? You have to use the terms of the original contract. So that was the original contract terms. That's the original mortgage. So now that you have what's remaining, remember this is from the other document, applications. If you go back and see that document, $2.5. To see how to do this. Okay, so you're using the old terms to find what remains on the old mortgage. Then you go to the new mortgage. So you have to get the bank to loan you this amount so you can pay back the old mortgage, complete that mortgage, and then they issue a new mortgage for that amount with different terms. So the new terms involve the new rate, which you will store in your calculator because it has repeating decimals, and you don't want to lose the decimals. It's 0.003333 repeating. And then so it looks almost like up here, right? It looks very similar. Actually, it is the same. But what I'm doing now is looking for the payment on the new mortgage. So get your head around that. Okay, so those are the steps. You find out what remains, and then you get the bank to give you that amount, and they give you new terms, new mortgage. Okay, let's look at question 6. Did you guys want to finish solving this and then we'll go to 6? So for the second part here, what you're going to enter again, well, these are already in your calculator. 240 is an N. And now you're going to put the new recall 1, but don't forget to multiply by 100, right? To put it in the time value of money keys. So you times by 100 and you enter it into interest. And then you want to find the payment, so you don't put that in, but you put in the PV. So what you should have done over here, I think I just used the regular. Let's see if I didn't store 179, so but let's put 179,863.78, as though that's what has to be borrowed. And that's going to be borrowed, so that's a positive. And then 0 into FV and ask for the payment. So compute payment, the new payment. I want to make sure that, oops, I want to make sure the decimals are right. I'm just calculating. Yeah, it works if I just put that number in there. Maybe in some problems, I might store all the decimal places for that principal amount, the borrowed amount, for the refinance loan. I'm going to check if you get the same. Well, anyway, let me know if you have any questions. Okay, let me go to 6. Okay. So Javier wants to accumulate $40,000 by the end of 18 years. So what he's going to do is invest in mutual funds to do that. He's going to deposit an amount at the end of every month for the next 18 years to get what he needs. So mutual fund is an investment. It's like in the way that pensions are a fund that a person contributes to, other people contribute to the same fund, other employees contribute to the same pension fund, and that becomes a large amount of capital that then gets reinvested by the investment bank, whoever's holding the fund. You have a pension manager. If you work for a large company, then they have their own pension division, and they have staff or they hire people to do the investment of this large amount. So when you have a large fund, you have different capital markets available to you. Pensions are usually invested in a more safe or fixed assets like bonds and less risky assets. But mutual funds will engage in investing in diversified portfolio of risky and riskless assets. So they might offer a higher return as a result. but with the additional risk. So anyway, this fund has a return stated as 0.5%. And I said a stated monthly rate of return. So we know, because it's stated, what this is R112. So I need to take that number and divide it by 12, and I get this number. So this is really the return on an effective, and this is the effective rate. This is effectively what you're getting every month if you invest in this mutual fund. But as I explained in the summary page, you need the rate that is equivalent in timing to the timing of payments. Deposits are each year, so I need EAR. That's how I know what rate to get. What do I have? I have the monthly rate. What's the relationship between the effective monthly rate and the effective annual rate? Which one is smaller? This one is smaller. Well, that didn't work. This one is smaller. The monthly one. So I need 12 of those in factors to make one factor of accumulation over the year. So I make the calculation and I store this number. Shall I make this a little bit bigger? It looks like it might be blurry. Okay, make sure you can make that calculation. So when you review these videos, you can put me, you can speed up my voice, because I am doing things very slow, I'm finding. You can speed up my voice and move through these, and I promise you timestamps, and I haven't had a chance to put the timestamps in. If anyone knows how to do that, you can do that too. You can put the timestamps in the comments, and then you can share that with everybody as you review the video. Then they can get through the video much faster by just watching the parts that they want to review. Okay, so I have that. I have that rate that corresponds to the annual deposits. Then I need to figure out how I'm going to make 40,000 over 18 years, 18 annual payments. So what's this? I'm saying I want the future value to be 40,000. So this is the formula here of the present value at time 0 times, I'll put it over here so it looks more familiar, 1 plus EAR, which is just the interest rate for 18 periods, to get the future value at the end of 18 periods. So what I've done here is put together the annuity, this is the annuity, that gives you the present value, times this accumulation factor. I put it over here just so you can see. It's essentially the basic time value of money formula. But to find the present value, I have to get the annuity. That's all I have information for. So this is the future value of 40,000. This is the present value annuity. So let me write it here how it looks. So this is FV18 is equal to 1 plus I. It's just in a different order. So you should strive to see the similarity between what I'm writing here and what we've already done. There's nothing new here. I'm just combining things you've learned. Yeah, that's how I've written it. So some classes and some textbooks actually create a formula for this, but I prefer not to make like a new formula. But it's up to you if you want to put these as a formula on your formula sheet, something like future value of an annuity at time t equals okay, so that is the long version, and some people use that as the formula. Oh, sorry, not 18, but T. This is okay. So they do that, or they combine them and they distribute this 1 plus I inside. But why teach a new formula? I don't see the need. But if you like that, you can put this on your formula sheet as the future value of an annuity. The main reason I don't bother with this is because you can just ask your calculator for future value using the same steps as before. So it's not really a new formula, it's just the original formulas. Future value of an annuity. Can you see all that? Questions? Okay, so let me finish this one. So what I do in my calculator to get the payment size is I enter 18 into N, and interest, what was the interest rate? I gotta go back. Okay, so you would have stored this, right? You would have made this calculation and stored this value. So you would say recall 1 You guys see? And then the future value amount that you would have would be 40,000. No, that's future value. So that means you would put 0 into PV, right? I'm doing these out of order, but so make sure you have 0 in PV. And then you ask to compute payment. You see how this works? That's why I'm giving you the calculator. That's how a pro would do it. And if you want to practice analytically solving, but you probably did that in 3106, so I don't want to be doing that in this class. You should be able to use the calculator now. So then the second, so any questions about that? When you compute, you should get this. As a negative. I have too many zeros in my answer below. I don't know what I did in the second part. Let me think. That's weird. So, any questions about part A? So he would have to deposit $2,129.06 every year at that rate every year. The rate ended up being it's very small, right? Not a very high rate. But this is the commitment of the mutual fund. So it's 0.5% a year. Okay, so I do get that number when I recompute. But then I ask the question in part B, how much a single lump sum deposit today needs to be to accumulate to the necessary amount. So alternatively, to have $40,000 by only making one deposit, how much would he have to deposit today? That's the question. So it's a basic time value of money problem. I want to know how a person just making one payment Now, would accumulate $40,000. So I just want it's such a low rate. It's such a low rate, doesn't have to be much different. So let's see if I got it right. So if I put in 18 years with that rate, $40,000 is my future value, no payments, and compute the present value, and that's what you get. So this is a basic time value of money problem where you put 18 years, so you already have this data or these values entered into your calculator, but I'll do them again. Recall, remembering these keys that you punch should not be written on your test. They're not going to gain you any points. It's just for you. You make sure you put 0 into payments, because now I just want to know what lump sum, not payments. So I'm going to put 40,000 into future value and ask for the present value. And this will be a positive because I'm going to make a deposit today, or Javier would make a deposit today of this amount, which looks very much like 40,000, but it's because the rate is very low. Okay, so a question about the rates. Let's see. Let me make, first of all, it looks like you can't see what I wrote. So let me fix that. And then the question about the rate. So we got to read this carefully. Go back up. What it says is stated monthly rate, and we know that means that they are giving you R112, which means .005 over the year as simple interest. So that's not effectively what you get. It's very similar, they're very close, but it's not the number the bank will use or the investment bank will use or a mutual fund company will use. They're going to be using, thinking that their rate, this is what they're going to give you for every month that your investment continues to accumulate. They're going to give you this, EPR 112. But what they tell you is that they're giving you that over the year. That's not accurate though, right? Over the year, what you're really getting is this amount. That's what's equivalent to a year. And it turns out that that's higher. This is just going to give you the 5%. So this is a convention in the financial markets so that people staring at mortgages can compare them across the board. They're all written as APRs, where they they compound monthly, and they just state the simple interest. So you can compare them across the board, but to make calculations like we're making right now, we need the effective rate. So as long as every type of product across the industry uses the same stated rate, it's kind of fine because you can compare stated rates to stated rates. But when you want to make calculations, you need to convert them. This is the point I'm making. So in stated rate terms, this is 0.05, but in effective rate terms, this is a little bit bigger. And it's going to throw off your calculations. And so you're like, oh, it doesn't really matter, it shouldn't really matter. Well, banks are operating with all these decimal places. You should know how to replicate their numbers. Okay? Now this is just a $40,000 amount, but the banks work in trillions of dollars. Financial institutions work in large sums, and they need to keep track of their decimals. The computers do that for them. I have to make this visible to you. It's a little bit off. There you go. Okay. So we spent an hour and a half just reviewing. Let's do some more review. What else? So those are the questions students have given me so far. There you go. That's a better view. Just to recap, because you couldn't even see what I was writing. This is the one they give you. And you would compare that to an effective annual rate that's a little bit bigger. And your numbers, your figures will be off. Your calculations will be off unless you're using this one that I calculated using the conversion from effective to effective rates. Okay. So I was going to look at the prep document for the next hour. Should I take a few minutes break? Let's take 5 minutes, and when we come back, I'll look at the prep document, test prep. Okay, I'm back. Okay, so you guys aren't asking for anything in particular, are you? I'm going to the prep problems. How many of you have done all these problems? So you have all the solutions in 217. Who wants me to work through these, or are there certain problems you would like me to do? Or should I just start from the beginning? From the beginning? So if I'm going to start at the beginning, and Tiana, I'll start from the beginning, and I will make sure I cover 4 before we leave, okay? So let's see. I'm going to put up my iPad, my old iPad. Let's start solving. Sorry, it's taking forever. I'm trying to get it bounced. Okay. So the first problem was, oh, now I lost everything. What happened? What happened? You got a white screen. Okay, let's start writing. So the first problem, just cleaning my workspace up. Sorry, I'm here. Putting things away. Oops. So if the EAR is 15%, find the equivalent rates. Find the equivalent rates. First, we want the semi-annual rate compounded semi-annually. The semi-annual rate compounded semi-annually, because those are the same, both the compounding frequency and the statement, the period over which the rate is being stated, are the same. We want to find for the first problem an effective annual rate. Sorry, an effective periodic rate that's semi-annual. So what I'm doing is I'm using those formula that I've introduced you to. I'm just going to pull up that form. So that was 2.3. From document 2.3, right, remember this? So we have two formulas. I could erase all this for you. I'm not sure if that's going to help or make it more confusing. So one is to convert between stated and effective rates, and the second is this equivalency between effective rates. So we want to use this second part, right? We want to make use one of these pairs. So what is the equivalency string of equalities are that the effective annual rate here is equal to the semi-annual effective rate like this. Okay, so let's do that. So that's the document I'm going to refer to, document 2.3. Again, if the screen gets blurry, just refresh. So how do I get the effective rate? So I write what I need and what I'm given you're given the effective annual rate, but you need the effective semi-annual rate. So which one is smaller? The semi-annual rate is smaller, and I need 2 of these to make 1 accumulation factor of a year. Those are equal. So I take the 15% here, and I solve for, so I always set up this equation until I get the hang of this. You can memorize formulas like you could, I'll show you what I mean. You can put certain formulas on your formula sheet. But it always comes from these first principles. All right, so the subscript is not a number. Uh-oh. You're not seeing what I'm writing. What happened? I have to refresh something. So I have to do the whole thing again because we didn't see that. So let's go back. I'll repeat. Or I'll erase. So this is how I set things up. What you need and what you're given. What you need is the effective semi-annual rate, the effective periodic rate over half a year. But what you've been given is the effective annual rate. What is their relationship? The relationship is that this one is the smaller one, the semi-annual one. So I need 2 factors of these to make 1 factor of annual accumulation. Now those are equivalent. You can check on that list of formulas. 2 semi-annual periods make a year, and effectively these will be the same thing. They'll give you the same answer. So now I take my amount, 1.0515, and this is equal to 1 plus EPR squared. So what I have to do is take the I'm gonna make this fit better. Gonna make this fit better. There you go. It's so messy. This, I don't like this. Don't like this setup. All right, so that's 1.15. Okay, so what I need to do is take this annual effective rate and for every dollar invested at time 0 each year, that would accumulate to $1.15, right? But I want to figure out, what if this happened? Let's say I arrange with someone, they borrowed money from me, and then they show up early. They show up at 6 months, half a year. And even though we arranged for every dollar they borrowed, they have to pay me back $1.15. So you can see this. Let's say they borrowed $1 million from me, then they have to pay me back an extra $0.15 million, or $150,000. But what if they showed up early? What would be the equivalent amount if they showed up early? Does anybody know? That's essentially what you're solving for. You're finding the effective rate over half of a year, so that you could use that in case you needed it. Okay? In our case, we need it because payments are occurring at half-year periods. Well, actually, I didn't have a storyline here, but we would need it. So I could use it for payments. I could use it for this situation where someone shows up early to pay me back, and I have to give them a fair amount. So what would that amount be? I have to give them fair terms. So what I need to do is take that amount and divide it by 2, but not divide the number by 2. I divide it in the exponent, in the powers. And this would give me the effective period rate over half of a year. Again, I gotta position this. There's not a lot of space I'm working with. Okay. So that's what you're figuring out. Now, if some of you are having trouble entering this into your calculator, you need to let me know. So what do you get? When you do this, you find the rate 0.0 0.723.805. So follow the directions how many decimal places I want in a test situation to get this right. In this exercise, how many did I say I want? So 8 decimal places if expressed as a decimal, or 6 if expressed as a percent. I'm reading the instructions. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I just need to round that to 3. Okay, so then back to the original question up at the top. How much would the person that borrowed from you for every dollar, how much would they have to give you? Would they have to give you $15 divided by 2? 7.5. Is that how you would figure it out? So if they showed up early, would they give you $1.08? Or we can write it like that, 1.075 for every dollar they borrowed. Is that how you do it? Well, no, you just found it down here. That would be too much. That would be unfair. Okay? The equivalent rate is actually .072, not .075. Okay, and you can say, oh, that's not a big deal if it's just dollars, but in the millions of dollars, that makes a difference, doesn't it? So it should be 1.07. I'm going to do it in a different color. It should be one in blue, 1.0723853 for every dollar. If it's in the millions, all those decimals are going to matter. Okay, so it's a little bit less. So if the person who borrowed from you comes up with that, to be fair, you would have to say, no, that's too much, and give them a credit, give them some money back. Any questions about that? So that's what you're figuring out. Whatever you're going to do with it, that's the storyline you can imagine. Okay. Let's do the next one. What's the next one? So using the same effective annual rate, let's find the annual rate compounded quarterly. So what do we want? So for part B, you want the annual rate compounded. This stands for compounded quarterly. So what you want, since these are different, it says annual and this is quarter, I know I have to get the R1 quarter. R1 quarter is taking the effective period rate. What they did was take the quarterly effective rate and multiplied it by 4. So they just ignored the interest on interest. These are supposed to be equal intervals. So really there's an effective periodic rate of running over a quarter of a year. But they didn't care about that. They don't care about the accumulation of the fund. All they did was take that and multiply by 4 rather than using 1 plus EPR 1 quarter and then 1 plus EPR, then another factor of growth, 2, right? Rather than growing it over until the end where it's 1 plus EPR 1 quarter to the factor of 4. That's not what they're doing. All they did was take it and spread it out over the year by multiplication, simple interest. So we want to find what that is from an effective annual rate. From the top, we were given the effective annual rate of 15%. Find the equivalent
R1/4. To do R1/4, you first need to get EPR1/4 and then multiply it. So those are the steps. So step 1 is to get this. And step 2 is to multiply it by 4. So let's do that. I'll erase this graphic here. That's what you should be thinking about. At any point you can take screenshots if you feel I'm rushing. You want to review things. So what we need is the effective quarterly rate, but we're given the effective annual rate. What is their relationship? Which one is smaller? This one is smaller. 4 of these accumulate to make 1 factor of the effective annual rate. So I can figure out, and now you guys are getting better at the pattern, I hope. This is just 1.15 partition or cut into quarters, but in the exponents, not in the denominator. That's the formula. So if you see this pattern, you know, you can see this is like a formula where this is a quarter here and that's just notation over here for EPR1/4, but this works as an exponent over here. So let's practice punching this in. If people don't know how to punch this in, you're going to do 1.15 on your calculator, or maybe you're using a different calculator, but to use the one I've asked you to buy, you're going to say 1.15 y to the x there you go, y to the x, and then you can put 0.25, which is a quarter, or you can use brackets, or what I like to do is write 4 and flip 4. I like flipping. So these are keys. So 1.15, 4, flip the 4 in the exponent, and then say equal. How's that? And then -1. That should give you the answer here. So try my trick. Even though you have your own system figured out, try my trick. Because, you know, when I give you a test, you know, you're allowed to use whatever you have at your disposal, except another human. That's what the rule is. But I give you or allocate a certain amount of time for each question. So if you're just punching away at a different using a different calculator, you waste a lot of time. All right? I do want you to practice being efficient in entering these amounts into your calculator. So what do you get? Looks good. So 0.03558,076. Oh, is that 8 decimal places? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I can round this to 8.
How's that? What's next? Am I finished?
So that was step 1. So we would compare that number if
Anyway, let's finish this and then I'll compare it. Right, this is right, I see what you're saying,
Von Marie. Yeah, you're not supposed to round it in your calculator, but I just, to put it on the paper, I rounded it. To put it on this document, I rounded it. But she's right. Don't in your calculator round anything. There's more numbers here. Okay? More digits. So what do we do next? Step 2, multiply by 4, and that's it. So let's see if I can take this and put that there with an arrow, because I otherwise have to change the page. There's no room on here and I can't shrink this. So I'm going to take that amount and times by 4. So my answer is 14%. I don't know where to put this. Step 2. You take that amount and multiply by 4, you get R1/4 with 8 decimal places is 0.14. Or in percentage, I'll make it in percentage, 14.2 232. It's not going to fit. Something like that, right? 32. I'm going to say equals. For your final answer. Okay, so it's like 14%. Right, I should just round it to 1. Or you can put it as a percentage, 14.2232331%, which looks really messy, so that's why I didn't do it. Okay. So step 1, step 2, multiplying. So that 14% is different than if you actually had the effective annual rate. That's what you would compare it to. The stated quarterly rate is not the same as the effective annual rate. That's the main point I'm making with all these problems. That's underlying solving all these problems.
That's why we go through all this trouble. Questions? So Ariette, if you notice, all the problems that I gave you,
it's usually per year compounded something, right? So these are R's. RN is per year compounded whatever. And so this is the fraction of a year. So this is so it's usually nth. In English you say nthly. But if there was a question that said per semi-annual, and I didn't get you to do this, but you should be able to do this. I think I asked something like this. I just didn't get heavy into it. But you should be able to do problems like per semi-annual period. Let me write what you wrote down.
you wrote,
Okay, per semi-annual period compounded annually, you should be able to do that. Let me write this a little bit lower. So per semi-annual period compounded annually, you should be able. How would you express that? What symbol would I give that?
I think for this one, to make it a little easier,
Before I do that one, what if I said how about the problem we just had? What about per semi-annual period compounded quarterly? How would I write that? So if they don't match, it's always an R. Always an R. We always use R as a symbol. However, because it's per half of a year, you have to put the half in front here, because remember, a stated rate is in portions of a year. I'm too close to the button. So, and because the statement is a fraction of a year, I just divide. So because it's stated, it's simple interest, I just divide, right? I divide. And then what is the subscript? For here, the subscript would be quarter, because I said quarterly. And what would the subscript be here? It's just a 1. What's R1? So I didn't ask these questions because it can get confusing, and I lose the whole sense of what I'm trying to do. But yes, you could find these. R1 is what? Where EPR1 is also equal to effective annual rate, so is R1. If you're going by annual, that's always a subscript 1. Remember what R is. R is the rate per year, and then nthly. If it's annually, then it's just a 1. Where nthly refers to the fraction of a year. So quarterly would be a quarter. Daily it would be 1/365. So this is confusing for some people, so that's why I don't do this. But you should be able to do this, okay? You should be able to solve any of these and interpret these. So are you with me? So that's what Rn is. So what you would do here in this problem is you would find that you just take the EAR and divide it by 2, and that would be that. Per semi-annual period compounded annually. And for per semi-annual period compounded quarterly, you get the quarterly stated rate and you just divide by 2. So I actually have a problem like this where I state different than saying per year, but you just use division. It's simple interest. You just divide, nothing more complicated. Okay, so if I apologize if that confused anyone, but you should be able to do this. So review this part of the video so you can follow that. And I do have a problem kind of like that one in here. Okay, so let's continue. We did the first two. So let's do continuously rate compounded continuously. That's the next one. So the effective annual rate is still 15%. But you're asked to find the annual rate compounded continuously, and I taught you last class, or you reviewed it. Annual rate compounded continuously, I taught you about the symbol R0. That's what you want. What is R0? So we go back to, let's go back to the notes.
this one. I have to fit it in again. As I moved it around. So let's go back to looking at this together. Now I plopped in, I positioned the discussion about R0, explaining that it's continuously compounding, so it's the smallest possible interval, instantaneously. And so I move along from the annual effective rate to semi-annual to smaller quarterly to smaller monthly to smaller daily to the extreme continuous. And you see the pattern all the way through. This is the most extreme. And I call this wild limit expression this. E to the R0. So I tell you that you learn this in calculus and mathematics. You learn that the exponent function is really the limiting function, a result of the limiting function. So what we know is, and you never have to write the limit expression again, I just want you to pull out of here this part. That 1 plus EAR is equivalent to the exponent R0 to the the exponential function to the power R0. So I solve this 1.15. So again, I can write this as this is given. Well, let me say in the order. Let me do this a little slower. So this is the expression I know about. So in this problem, I need R0. That's what I'm asked for. You guys aren't following because I didn't show you the drawing. Okay, so this is what we have so far. We're given this, but we need this. This is the equivalency statement. So this is the new part, right? This is something new for you, but now you know it. So now we solve 1.15 equals e to the R0. How do we solve for that? You take the log of both sides. You do the inverse function, in other words. So R0 is equal to that. To punch this into your calculator, it's 1.15. Log, natural log. That's it. It's actually very easy once you accept that this is, once you accept this relationship, you can use it. So R0 is 13.976, or let me write it as a decimal, because that's how you'll see it in your calculator. 0.13976194. Or 13.9769194%. Questions? Next.
So as we're going through this, you're seeing different stated rates, right? Depending on the compounding frequency of the underlying effective rate. Now there is no EPR 0, okay, because that's not practical. We never talk about EPR 0. We just use this relationship here. That's the relationship between the continuously compounded rate R0 and the effective annual rate, and all the effective annual rates, but we never write EPR 0. It's not, you can't instantaneously accumulate interest. It's intractable. All right, next one.
So, in that sense, you see another use of the stated rate. Let's look at the next one. Okay, so this is a good example of what I think it was Ariette was asking me about different kinds of rates. So for this one, this is part D. Are we on D or E? 1, 2, 3, 4, D. I'll call it D. So find the annual rate compounded every decade. So these are different. Because these are different, I know it's an R that I want. But which R? Okay, so it's fine. This is the annual rate. But every decade, remember, this is supposed to be fraction of a year. But this is not a fraction. This is like 10 years. So that's what my subscript is going to be. That's what I want. But how do I get this? If I know that Rn is always let me see it write it the other way around. My subscripts. So we know that EPRN is always Rn divided by, oh, it's still the same thing. It's still equally confusing, right? Let's just do it that way then. So Rn is E equal to the effective annual rate multiplied by the number of periods of compounding in a year. That's my best way of explaining how to do this. So, where n is usually a fraction of a year, I wanted to make this 10.
So what I wrote in the solutions is I flip this around. Because I'm going to need to get this first. And then multiply by the numbers of periods of compounding in a year. So for Rn, what are the number of periods? So R10, let's think about this. How many periods of compounding occur in a year? What does R10 mean? It's compounding every decade. It's not even compounding in the year. So to think about this, let's just use the last example that we had. What was the last one? R quarter, right? So we had, for instance, for an example, R1/4 is equal to EPR 1/4 times 4. But right now in our problem, we don't have fractions here. We have more than a year. We have 10 years. So do all of the subscripts flip? All of the numbers flip? Yes, they do. Okay, so what that's going to look like so everything's the same, but then I'm going to have to multiply by 1/10. Everything flips. Because it's 10 years. I'm going to multiply by number of periods of compounding in a year, but the compounding happens over 10 years. So in 1 year, it's just a fraction of the whole. Okay, so if you're accumulating over more than, if compounding doesn't happen until year 10, that's what this is saying. It's compounded every decade. Okay? It doesn't compound until 10 years. So what number of periods of compounding happens in a year? Well, out of the total, 1/10. All right, so this is the expression I'm going to use. So what it means is I have to get step 1, I have to solve for EPR 10 and then make the division. EPR 10 is not hard to find, even though I didn't put it on my string of equalities. You know how to get from fractions of a year to a whole year, so you should know how to get from 1 year to 10 years. So then step 2 would be to get R10.
Questions?
So let's do step 1. Take a screenshot. I'm going to erase. I'm going to stay on this page. So R10, so I need EPR10, but I'm given EAR. So what's the relationship between these? Which one is smaller?
Ah, it's 11:45. I get to stop. Let me finish this one. If you have to go, you guys can go and just pick up where we left off. Okay, I'm going to say goodbye to those who have to go. I'm just going to finish this, and I'm going to ask you to send me an email with any problems you want me to solve, and I can make a video and put it up. So send me an email of any problems you want to see solved by me, and I will make a video and put it up, because next week you have your test on the weekend. So the next class we'll do some more review, but you can see review is pretty slow. It'd be better if you guys didn't waste any time, and if you're stuck somewhere, let me know and I can make a video and post it. Okay, so for people who have to go, goodbye, and those ones who are here, let's finish this. So the relationship, yes, EAR is smaller. So EAR is the smaller one. 10 of these make one of these accumulation factors. So I want to solve for, it's just an accumulation of 10 years. That's basically it. So that's the effective rate over 10 years. One rate over 10 years. So it should be pretty high, right? So now when you get it out of your calculator, you see 3.045 57 I'll say 58. So I'm just writing to put it down here, but there's more decimal places. But that's not the percent, that's the decimal. As a percent, it actually is 304.5558, etc. Okay, I'm too close again to the, so I'm just gonna say I'm gonna write on top. So that's the decimal. This is the decimal result. What about the percentage result? That would be 304.5558.
or however many decimals I want. Okay, so that's big, it's 10 years, so that's the equivalent rate over 10 years, just one period of compounding, no compounding in between. That's 304%. So for every dollar invested, you get 3 and some more. Then the question is, turn that into an annual stated rate. So what we're doing is I want to do this with a graph. So it went from $1 becomes, for every dollar invested, it accumulates to 1 plus EPR, EPR 10. But what I want you to tell me, that the actual question is, what is the equivalent, not the equivalent, but what would be the stated rate over 1 year? So what does a stated rate do? It ignores all the compounding impact. It just cares about simple interest. So all it does is take that number and divide by 10. Okay, so this is over the whole thing. But all I want to do is to state that so that people can compare that across stated annual rates, and present that, even though it's going to be, it's not going to be useful for our formulas. We need to divide that by 10. So that's going to be 304.55, whatever. I do it really nicely in the notes. 5557. Divided by 10. That is the stated annual rate compounded every decade. Where this was a percent, the answer is a percent. Any questions? The final answer is 30.45%. For 6 decimal places, if expressed as a percentage.
questions? Okay, so I'm gonna stop there. So let me know which ones you want me to work out, if it helps you. I know this one is a little bit confusing, but if you just look at the patterns, you see the patterns are consistent. The patterns are consistent, and stated rates just want to be stated over the year. They don't care about being accurate in any sense of for our formulas for accumulating interest. They just want to be stated in simple interest terms over the select period. So with that, I'm going to sign off. Have a great week. Let me know any problems you want me to solve so you don't delay any time. But this is it. Those are the questions you have to work with. So the test will be some questions like the ones that you're practicing. Obviously not the same because you're going to have all your notes to work with. So they should be challenging and your work should be your own. If I identify any similar errors, I'm going to consider taking marks off, but if it looks like you're copying, I'm going to take double the marks off, okay? So it's very uncommon that people make the same mistakes. Well, the kind of mistakes that sometimes people make the same mistakes, but the kind of mistakes I will identify or my grader will point out to me, it will be clear that there's some infraction. So don't copy other people's works. They could have errors in them. You're all pretty much at the same level. You've been studying for a while. You're very good at what you do. So count on yourself and build your understanding. I don't mind if you all study together and you work on problems, but when it comes to the exam, you should be doing your own work. Okay, so that's for next week, next weekend. Make sure you set time aside to have the test on Saturday. You should read the prontuario to clarify any questions about the exam, but I did mention I would give you a block of time, and you can take all the time or you can just take an hour and a half, which is all you'll need for the exam in my opinion. Ricardo, I don't know yet how many questions I have. It's going to be enough questions that you should be able to finish the exam in an hour and a half. That's how many questions there are. So you should be efficient in solving problems. You should understand all the questions I've given you before the exam. So make sure you let me know if you don't understand something. Oh yeah, there's supposed to be an assignment on Connect, that's right. But yeah, I was supposed to give it to you. But I really want you to focus on these materials because my exam will be on these kinds of questions. I should be giving you Connect because I need to give you assignment problems. But focus on this first. I'll let the Connect questions be due after the test, so you have some time after the test to do the Connect questions. I'm going to verify, I think, I'm just going to verify that the hours that I provided on the prontuario, I specified the hours for the test. Okay, what I said on the prontuario is Saturday, September 26th from 9 till 3. So you have 6 hours to finish an hour and a half test. So you have to find some time in there to work on it. So I expect you to answer the questions. You're going to download them. I'm going to email them to you, sorry. You're going to download the questions. You're going to write your answers on paper. No typing allowed. Has to be written in your own handwriting on separate pages. 1 question a page. If you need 2 pages for a question, that's okay too. You shouldn't though. Then you're going to fax it, you're going to email it back to me. That's how we're going to deal with the test on Saturday. Okay, goodbye. I'll stay back for a minute or so if you have questions still.